Hello everyone. In our study today, we aim to unveil articulatory details of velum actions in the production of nasal consonants. Velum action is difficult to observe directly, and nasal consonants to date have mostly been characterized with acoustic or aerodynamic data. So here, our study uses real-time MRI to obtain articulatory kinematics of nasal production. We use two test beds in Korean. First, spatial velum actions are investigated for syllable onset and coda nasals in Korean, which reportedly have different degrees of nasality. And second, temporal velum actions are examined for single or final nasals versus longer nasals spanning a juncture. For spatial results, we compare onset and coda nasals, and as Korean onset nasals exhibit nasal weakening, we predict that onset nasals will have less velum lowering and or velum opening. In terms of the temporal action of the velum, singleton coda nasals and long juncture geminate nasals are compared, with the prediction that lengthening of the nasals across the word boundary will be evenly distributed across the entirety of the velum action interval, as has been seen for oral geminates. Data obtained by 3 native Korean speakers using real-time MRI is analyzed with an automatic central tracking tool that tracks the pixel intensity weighted velum centroids for each video acquisition frame. Results on spatial velum action show that onset nasals are indeed differentiated from coda nasals in the displacement of both velum lowering and opening. The denasalized onsets have smaller displacement than the syllable codas, as you can see in the box plots on the left. With regard to the velum's maximum vertical lowering, this lowest position of the velum does not distinguish onset nasals from coda nasals. Instead, it is the velum's opening extremum that significantly separates onset nasals from coda nasals, with onset nasals showing less extreme velum opening than coda nasals. As for temporal pattern of the velum actions of the singleton and long juncture spanning nasals, the intervals of velum lowering movement and plateau duration did not differ between the short and long nasals in Korean. Instead, the length distinction was found in the velum's raising duration. In sum, the study's findings illuminate the role of velum actions in linguistic nasal production and show that variation in the linguistic characteristics of nasals requires an understanding of the geometry and movement components involved in the spatiotemporal action of the velum lowering, opening, and raising. This work further demonstrates the utility and efficiency of real-time MRI as an instrumental tool for studying human speech production. Dynamic MRI particularly allows for a unique window onto understanding kinematics of non-oral and non-constriction speech gestures, such as velum gestures. Thank you, and please reach out to me for more discussion.